Our next point of discussion is how to pass and return two-dimensional array references to methods. There is no difference between passing a single or two-dimensional array as an argument to a method or as a returning from a method. And we have already learned how to do that on a single-dimensional array. The method must accept a two-dimensional array as a parameter, both in actual parameters and informal parameters. Consider the following program. Let us first focus on the methods that are available in this program. We have two methods. The first one is called showArray. The second one is called arraySum. The purpose of the first method is to display the two-dimensional array row by row. The input parameter is a two-dimensional array of integer. It is called array. And as you can see, we are processing the array row by row. After printing the values of each row, we print a new line so that we print the two-dimensional array in a tabular form such that each row is printed on a separate line. The second method is called arraySum, and it has also one input parameter, and it retains the sum of all elements in the array. The implementation of this array, it doesn't matter if you process it row by row or column by column, because you are going to visit every element in the array one by one and add it to total. After finding the total, the method retains the total as a return value from the method. So this is how formal parameters are defined for two-dimensional array. Now let's go to our main program. In our main program, we have an array of integers of size 3 by 4, and it is already initialized with some data. Now to call the method for printing the array in a tabular form, you just simply supply the name of the two-dimensional array as an actual parameter. So simply you write the name of the array numbers, and since numbers is defined as a two-dimensional array and the formal parameter defined as a two-dimensional array, so simply the two-dimensional array is passed as a parameter to the method. And to call the other method to find the sum of all elements of the two-dimensional array, simply you call the name of the method and you pass the two-dimensional array as an argument. Notice how we are passing the two-dimensional array. You simply give it the name without any square brackets. And notice how we are defining the formal parameter for the method arraySum. It is defined as a two-dimensional array of integers. So when the method is called, it will compute the total of all elements and will return the total as a return value of the method. When this value is returned, then it will be printed on the screen by the main program. And this is how two-dimensional arrays are passed, and this is how two-dimensional arrays are declared as arguments in two methods. To show you how two-dimensional arrays are passed as arguments to methods, let's take a practical example. In this example, we want to write a Java method called getBorderSum that takes 3 parameters. The first parameter is a two-dimensional array of integers. The second parameter will be the row size, and the third parameter will be column size as parameters. The method should calculate and return the sum of all integers around the borders of the array, as the following example show. For this example, if the array size is 5 rows by 4 columns, and it contains the following numbers. Now where are the border cells? The border cells are shaded. So the first row and the last row, the first column and the last column. Then the method should sum all the numbers around the array borders, which are shown here in highlighted cells, and return this sum. In this example, the sum is equal to 2 plus 1 plus 0 plus 7 for the first row, and then 1 and 4, and 3 and 6, 7 and 10, and then 1 plus 8 plus 6 plus 5. This assumes that the row and column parameters should not exceed the row and column lengths. So in this example, in this method, we are not going to depend on the capacity of the array. In other words, we are not going to use .length. We are going to depend on the parameters row size and column size. After understanding what the method is supposed to do and what it's supposed to return, the question is how to implement the code of the method. In other words, how to find the sum of only the elements that are on the borders. Do we need to visit the elements of the array, row by row or column by column? In fact, you can do either of them. Why? because you are going to visit every element in the array, the thing that you should do when you visit that element is whether it's on the border or not on the border. So inside the nested loops, whether it is row by row or column by column, whenever we visit an element, we need to see whether this element is on the border or not. So where are the borders and how we can locate them? Notice that the border values are at row 0 and column 0. And also, if we have this two-dimensional array, its size row and column parameters are given to the method, then we can say that the last row is at index row -1 and the last column is at index column -1. So in fact, the borders are at row 0 and row -1 and at column 0 and column -1. So when we process the array, row by row or column by column, we test for these 4 parameters. If any of these elements is located on any of these parameters, then we add it to the sum variable. In fact, we can process this array in more efficient way than row by row and column by column, because row by row and column by column, we are visiting some elements that we are not interested in to find their sum. We are interested only for the elements that are on the border. We can do that by writing 2 separate for loops, not nested loops. The first loop, we make it find the sum of the 2 rows, row 0 and row 1. And the other loop, which is separate from the first loop, we make it find the sum of the column 0 and column -1. First, let us implement it by processing the array row by row and give you the answer. And then we will show you the efficient way of processing this array without visiting all elements of the array. We visit only the elements that are on the borders and we add them to sum. So let's go to JGrasp and implement the first way by visiting the elements row by row and test for the border elements and we add them to the sum variable. We have prepared a demo program to test the method getBorderSum. We have an array initialized with some data. We want to find the sum of the border elements of this array by passing it as a parameter to the method getBorderSum. Let us first define the method and then we will show you how to call this method. We will define it inside the same class where the main method is. So therefore we have to define it as a static. Public static, and it's going to retain the sum of the borders as an integer, and we are going to call it getBorderSum. And if you remember, it has 3 input parameters. It's going to be a 2-dimensional array, and we are going to call it array, as well as its parameters, which is row and column of the 2-dimensional array. As we have discussed, that we are going to process the array row by row. So let us start writing the nested loops, and then we will think how to modify the nested loop to get the answer of what we want. So we will say for integer row equals 0, row should be less than. Now here we are going to have naming conflict because the input parameter is row and the variable we are using for the loop is also row. So instead I'm going to use just only R, which is short for row, for the nested loops, and we will leave row and column for the parameters. So we have R equal to 0 and R less than row, and we have R plus. Or there is a better way to do it, that instead of calling the input parameter row, we are going to call it rows, and for the column we are going to call them columns. And for the for loop we are going to use row, and we will say that row is less than rows and row plus. So this is for the outer loop that is processing the rows. And we are going to write the loop for the column. So for integer column equal to 0, column is less than number of columns, column plus. So now inside the inner loop, we need to test that the element is whether it's on the border or not. So which elements are on the border? As we discussed, those that are at row 0 and row -1, and those that are at column 0 and column -1. So we write an if statement, and here we say if row equal 0 or column equal 0. or row is equal to rows minus 1, or column equal columns minus 1. Notice that rows is the input parameter for the number of rows, and columns is the input parameter for the number of columns. If this is the case, then we need to add the element to a variable that is responsible for finding the sum, and here we say array row and column. And after we exit the nested loop, then we need to return the value of sum. But we need to define sum because it is going to be used inside the method. So we will say sum equal to 0, and we are going to make it equal to 0 because we are going to use it for accumulating and adding the elements of the border into it. This completes the implementation of the method. Now we need to test it. To test it, we need to call it from main and supply array as an input parameter. So we will say get border sum, and we will give it the name of the array, which is array. And then how many rows do we have for this array? We have 5. And how many columns? We have 4. We will supply this as an input parameter. But the method returns the sum. So we need to print the sum. So we can use it inside the print statement. So we say system.out.println, and then we will say that the sum of the border elements is, and we print the return value that is coming from the method to the output screen. So let us run the program and see. So after running the program, now it says that the sum of the border elements is equal to 61. So this is how to write the code for the getBorderSum method by processing the two-dimensional array row by row. But we can find an efficient way of processing the two-dimensional array better than visiting every element in the array row by row, because we are interested only to find the sum of the border elements only. So if we go over these rows and columns only, then our processing will be much efficient than processing row by row or column by column. So let me show you how to do that. So we need to write another method. I'm going to call it getBorderSum1. So I'm going to copy the header of this method, and we're going to implement it below it. So instead of getBorderSum, we are going to call it getBorderSum1, or we will call it extended. So getBorderSum extended. In this method, we need to find the sum of only the borders of the array. So where are the borders? The borders are at row 0 and at rows -1, and at column 0 and columns -1. So we need a for loop, and we will see what to put for this for loop. We need to find the sum of the elements that are on row 0. So we will say sum equals sum plus array, and on row 0, and we need to go over all columns. Also, we need to add the sum of the elements on the last row because they are on the last border, and we will say that array rows -1. So these are the elements that are on row 0, and these are the elements that are on rows -1. So therefore, we have to put the column here, the second dimension. So we have to go over the number of columns. So we will say column equals 0, column less than columns, and column plus. Now this for loop, it is not nested for loop, is responsible for finding the sum of the elements that are on row 0 and on rows -1, which is the last row in the two-dimensional array. Now we need to find the borders that are on the columns. So again, we will write a for loop. And inside the for loop, we are going to accumulate those, and we will say sum equals sum plus array row, and here we need to go over column 0. In addition to the elements on column 0, we need to add the elements also on columns -1, and we will say array row at columns -1. So what is the loop variable that we should use here? It will be row. But since row 0, the border elements of row 0 are already counted, So there is no need to include them again, otherwise we are going to add them twice. So therefore we are going to start from row 1, and we will say that row is less than up to rows minus 1. But why it is up to rows minus 1? Why rows minus 1 is not included? Because the last row is already included in the summation in the previous loop. So the first loop is responsible for finding the sum of the elements on row 0 and row minus 1. And the second loop is responsible for finding the sum of the elements on column 0 and the last column, which is columns minus 1. After finishing, we return sum, and we should not forget to define sum and initialize it to 0 because we are going to use it for summation. So this is how to implement the method in a more efficient way than processing by row or processing by column. Let us test it, and we are going to call it using the same array that we have used for the previous method. And here we are going to say system.out.println. Let me paste the call, then I will put the message, the same message, copy it and paste it for the second print. And we need to supply the name of the array as well as the size, which is 5 and 4. So now we need to test the program. Let us compile it. And now let us run it. It should give the same result as the previous one. And notice that it is given the same answer as the previous method that processed the array row by row.